This video is about optimization problems. In this video, we are going to solve problem number 3. Let us read the problem. Construct an open box with a square base and a volume of 256 cubic centimeters. What should the dimensions of the box be so that it would have a minimum surface area? This is the box. Each side of the square base is represented by x, and the height of the box is represented by y. Step letter A. Form the constraint equation. This is the box. The volume of the box is equal to x times y, or v is equal to x squared y, where v means volume. According to the problem, the volume of the box is 256 cubic centimeters. We substitute 256 for v and then solve for y. So 256 is equal to x squared y, and then y is equal to 256 over x squared. Step letter B. Form the optimization equation. This side of the box is x times y, and then this side is also x times y. This right side is also x times y, and then this left side is also x times y. So we have 4xy, and then the base is x times x, or x squared. So the surface area is equal to S is equal to 4xy plus x squared, where S means surface area. And then substitute 256 over x squared for y. So we have now S is equal to 4x times 256 over x squared plus x squared. This is equal to S is equal to 1024 over x plus x squared. And this can be written as S is equal to 1024x raised to negative 1 plus x squared. Step letter C. Find the first derivative. In step letter B, we got the equation S is equal to 1024x raised to negative 1 plus x squared. Using the power rule for derivatives, the first derivative, or S prime, is equal to 1024 times the negative 1 x raised to negative 2 plus 2x. This is equal to S prime, or the first derivative, is equal to negative 1024x raised to negative 2 plus 2x. Let us make this exponent negative 2 positive by bringing it down. So this is equal to S prime is equal to negative 1024 over x squared plus 2x. Step letter D. Find the critical value. We are going to equate to 0 the first derivative we got in step C. Negative 1024 over x squared plus 2x is equal to 0. And then solve for x. Transpose negative 1024 over x squared to the right side. Change its sign from negative to positive. So we have now 2x is equal to 1024 over x squared. Cross multiply 2x times x squared. This is now equal to 2x cubed is equal to 1024. Divide both sides by 2. This is now equal to x cubed is equal to 512. Extract the cube root of both sides. So we have now the cube root of x is equal to the cube root of 512. X is equal to 8 centimeters. Step letter E. Use the second derivative test. In step letter C, we got the first derivative s prime is equal to negative 1024x raised to negative 2 plus 2x. Using the power rule, we are going to solve for the second derivative. This is now equal to 2048x raised to negative 3 plus 2. This is now equal to 2048 over x cubed plus 2. In step letter D, we got x is equal to 8 centimeters. We are going to substitute 8 for x. This is now equal to 2048 over 8 cubed plus 2. This is now equal to 4 plus 2, and 4 plus 2 is equal to 6. 6 is greater than 0, therefore, the second derivative is greater than 0. The second derivative is greater than 0, therefore, the minimum value occurs when x is equal to 8. In step letter A, we got the equation y is equal to 256 over x squared. Substitute 8 for x and solve for y. So we have now y is equal to 256 over 8 squared. Y is equal to 256 over 64. So y is equal to 4 centimeters. This is the box. This side of the square base is the 8 centimeters, and this side is also 8 centimeters, and the height of the box is the 4 centimeters. These are the dimensions of the box that will give the minimum surface area. 8 centimeters by 8 centimeters by 4 centimeters.